distracted. Okay, so example 1 here, we are sketching a graph of the following function f of x, and you can see that I've already labeled my graph with f of x because I don't care about it, given this following information. So some of this information we're going to need to remember stuff from previous lessons to make sure we know what they are. So the first piece of information it tells me is that this graph is going to pass through the following 3 points. So we're going to plot those. -1, 8, 0 is over there. 2, 3, 4, 5, -2 is right there. 8, 3 is right there. So we know that this function is going to hit through all 3 of those points. We know that it has an absolute max. So that absolute max is the highest point. So that tells us that when we're drawing this in, we can't have anything higher than this point right here. It also gives us a little bit of function notation that we need to deal with. Remember that f of x is equal to y. So in this situation, the x is that -4, and the y is that 5 of what it's equal to. So we're going to go ahead and plot that. -4, 1, 2, 3, 4, 1, 2, 3, 4, 5. Count twice, plot once, and don't lose any points. So I'm just going to make a note here that this is my absolute max, that I can't go above that point, because that's going to be helpful. And then in the same boat as that is my absolute minimum, which, just like we did before, is at 2, -6. 1, 2, 1, 2, 3, 4, 5, 6. And again, just like I did before, I'm going to mark that as my min, so I know when I'm graphing this or making the function that I don't go lower than that. Okay, our next piece is talking about an interval over which it is decreasing or going down in a downwards fashion, something like that. And so these are just saying x when x is -4 through 2. And those are talking about x values, hence the big fancy x in the middle. So what I do for this is I just make that note on my graph so I know that it has to be going down. So -4, 1, 2, 3, 4. So -4 is right here. And I just use a dash line. X equals -4, right? And then 2, 1, 2, make that little dashed line there. And I know that when I'm connecting those points, I'm going to have to be going in a downward fashion. It's going to have to be going down. And then this last one is a little confusing. So when x is, what does that inequality say? When x is, use your hands, less than 0. And so let's think about for this sec. If x is less than 0, that means that x is what? How could we describe it if it's less than 0? Well, that would be negative. So when x is less than 0, f of x, meaning my y value, has to be greater than or equal to 0. So what this is basically saying is when, let me change that. When x is negative, y must be 0 or positive, right? Because that says, let's use a different color, greater or equal. Okay, so make sense of that using the graph. When x is negative, well, this is my 0, 0. X is negative to the left of that. So when x is over here, my y values have to be either 0 or positive. So where are there positive y values? So here is where we have positive y values. So when x is over here, I can't go below that x-axis. That's what that means, basically. not basically, it is what it means. So now I'm just going to go ahead and connect our points and make our graph. And remember, from our first piece of information here, is that when we have no mention that this is linear or a straight line or an equation of any sorts, so this needs to be curvy and smooth. All right, so I can't go below this x-axis, so that's a terrible curve. It's okay, I'm nervous. Okay, remember it's got to be decreasing through those entire red lines, but I have to hit that point, so that wasn't the greatest thing. And it may take you a little while. Ooh. See, that's not good either, because see how I'm not exactly touching that point? You would lose credit for that. So try again. Okay, that's good enough. Notice how it's curvy and smooth. I didn't just, straight up, boo, 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 connect the points that way. Garbage. Don't do that. Curvy and smooth.